Okay, so we're being asked to prove by contradiction. No positive integer solutions. Just clarify what we mean by a positive integer. So a positive integer, okay, so an integer is any whole number, positive or negative. So -3, -5, it goes -5, -4, -3, -2, -1, 0, and then 1, 2, 3, 4, 5, 6, and all the natural numbers. Okay, so positive integer is simply the natural number set, so i.e. 1, 2, 3, 4, 5. Okay, so it doesn't include any negatives, and importantly, it also doesn't include 0. If we were to use a symbol to describe this statement, it would be Z, the Z sign for instance, with a plus just above it. Okay, so that is what we mean by a positive integer. So we've got to decide whether there are any positive integer solutions, i.e. is there an x and a y that are both positive integers that would fit this statement. We're being asked to prove that there isn't, but the contradiction, we are going to assume that they are positive integers, that there are positive integer solutions, and try and prove that it would work. We'll find that it doesn't, and therefore we're able to show that there is no positive integer solutions. So I'm going to assume a contradictory statement that either x and y are positive integers. I know the fact that difference of two squares, x squared minus y squared, is equal to x minus y multiplied by x plus y. And now, with this particular question, it is important to appreciate that we can have two scenarios. We could have the scenario where x is greater than y, and we could also have the scenario where x is less than y. So which one is bigger and smaller? That makes a difference. Okay, and you'll see why in a moment. So let's go through each of those. So if x is greater than y, then we have a situation where certainly x plus y will be positive, and x minus y will also be positive, so if x is greater than y. So if each of those individually are positive, then we are going to have a situation where the product of those, i.e. the multiplication of them, is going to be positive. Now, more specifically, we can say that the x plus y, not only is it greater than 0, but if x and y are integers, then it's going to be a positive integer, okay? And the same for x minus y, okay? Not only is it going to be positive, but if x and y individually are integers, then the subtraction of a greater number from a small number from a bigger number, but it's still going to be a positive integer. So if you multiply two positive integers together, and they're not going to be the same, they're not going to be equal to each other, y is not 0, therefore x plus y is not the same as x minus y. If you multiply them two together, you're going to get a situation where, again, you're going to have actually a statement that is a positive integer. Now, the subtlety here, again, it's not an easy one because there's a lot of things that are being assumed here. But the key idea, if you're multiplying these two integers together, they're not, at least one of them is not 1. Okay, we can assume here that this x plus y is going to be is not going to be equal to 1, it's going to be greater than 1. And therefore, the result from multiplying the two things together is going to be a value that is going to be greater than 1. Okay, so it's certainly going to be equal to 1, i.e. x plus y, when multiplied together, is x plus y multiplied by x minus y is not going to equal to 1. So I've got an equals there with a slash through, meaning it's not going to equal 1. So we're going to do the same thing when y is greater than x. So in this instance, we're going to have the x plus y, again, is going to be a positive integer. And we're going to have the subtraction of x minus y, that's going to be a negative integer. And therefore, when multiplying those two together, we're going to have an answer that is going to be a negative integer. So, the reason for that being is if you multiply a positive by negative, you're going to get a negative. Therefore, the key thing here is, okay, i.e. it's going to be not equal to 1. Okay, so again, we can show that x plus y, okay, is not equal to 1. Now, we tried to prove that there were positive integer solutions. Okay, we tried to prove that for two positive integer values, that x squared minus y squared, okay, would give me 1. But I've not managed to get that. Each time I've actually proved that it's not equal to 1. Therefore, my original assumption that there were two positive integer solutions, it would work, and it hasn't. Okay, so by contradiction, I've not been able to prove the case. Okay, therefore I can say that, or at least two, or put therefore instead. Sorry, therefore no positive integer solutions. I'm running out of space here. For the x squared minus y squared equals 1.